Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 3 to the power of x squared plus 2 is equal to 27 to the power of x. Now, the first thing I'm going to do is I'm going to change 27 here to 3 to the power of 3, because 27 is equal to 3 to the power of 3. So if I substitute in 3 to the power of 3 for 27, I get 3 to the power of x squared plus 2 is equal to 3 to the power of 3 to the power of x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 3 to the power of x, that's going to equal 3 to the power of 3 times x, also written as 3 to the power of 3x. Now, if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is equal to n. So in this case, x squared plus 2 is equal to 3x. Now to solve this, I'm going to subtract 3x on both sides. So now I have x squared plus 2, x squared minus 3x plus 2 is equal to 0. Now I have a quadratic equation. And to solve this, I'm going to be using the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is equal to 1, b is equal to negative 3, and c is equal to 2. So I have x is equal to negative 3 plus or minus the square root of b squared, so negative 3 squared minus 4 times a, which is 1, times c, which is 2. Now I have this all over 2a, so 2 times 1. Now to simplify, negative of negative is positive, so negative 3 is positive 3, plus or minus the square root of negative 3 squared. Negative times negative is positive, so negative 3 times negative 3 is positive 9, minus 4 times 1 is 4, 4 times 2 is 8. Now I have this all over 2 times 1, which is 2. Now I have x is equal to 3 plus or minus the square root of 1, 9 minus 8 is 1, over 2. Now I have x is equal to 3 plus or minus 1 over 2, because the square root of 1 is 1. Now this gives me 2 equations. I have 3 plus 1 over 2, and I also have 3 minus 1 over 2. So for 3 plus 1 over 2, this is equal to 4 over 2, which is simply equal to 2. For 3 minus 1 over 2, this is equal to 2 over 2, which is equal to 1. So 2 and 1 are my values for x. Now to check, started with 3 to the power of x squared plus 2 is equal to 27 to the power of x. Let's first try x is equal to 1. So if x is equal to 1, now I have 3 to the power of 1 squared plus 2 is equal to 27 to the power of 1. 1 squared is 1, so now I have 3 to the power of 1 plus 2 is equal to 27. 1 plus 2 is 3, so I have 3 to the power of 3 is equal to 27, and 3 to the power of 3 is 27, so I have 27 is equal to 27. This is right. Now let's try 2. X is equal to 2. So now I have 3 to the power of 2 squared plus 2 is equal to 27 to the power of 2. Now 2 squared is 4, so I have 3 to the power of 4 plus 2 is equal to 27 to the power of 2. Now 4 plus 2, that is going to equal 6. So now I have 3 to the power of 6 is equal to 27 to the power of 2. Now 27 to the power of 2, that is going to equal 729. And 3 to the power of 6, this is also 729. So I have 729 equals 729, so x equals 2 is also a solution. So I have x to the power of x to the power of 5 is equal to 100. Now the first thing I'm going to do is I'm going to take the power of 5 on both sides. So now I have x to the power of x to the power of 5 to the power of 5 is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So in this case, I have x to the power of x to the power of 5 to the power of 5, and we can think of m as x to the power of 5 in this case, and n as simply 5. So, and also we can think of a as obviously x. So this would be the same thing as a to the power of m times n. So in this case, x to the power of x to the power of 5 times 5. And now this is equal to 100 to the power of 5. Now, if I have something in the form a to the power of m times n, this can be written as a to the power of m to the power of n, right? Well, a to the power of m times n, this is also the same thing as a to the power of n times m, meaning a to the power of n times m, this is probably equal to a to the power of n to the power of m. But because both of these two things are equal to each other, then this means that these two are the same thing as well. Meaning, if I have something in the form a to the power of m to the power of n, I can also write this as a to the power of n to the power of m. So in this case, I have x to the power of x to the power of 5 times 5, and I'm going to rewrite this as x to the power of 5 to the power of x to the power of 5. And now this is equal to 100 to the power of 5. So now 100 here, this is equal to 10 squared. So now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 squared to the power of 5. And now if I have something in the form a to the power of m to the power of n, remember this is equal to a to the power of m times n, so I'm going to be using this property for 10 to the power of 2 to the power of 5, so meaning this would equal 10 to the power of 2 times 5. And 2 times 5 is simply 10, so now I have x to the power of 5 to the power of x to the power of 5 is equal to 10 to the power of 10. Now, if I have something in the form a to the power of a is equal to b to the power of b, then this means that a is equal to b. So in this case, x to the power of 5 is equal to 10. Now to solve this, I'm going to be taking the fifth root on both sides. So then these two cancel out, and I'm left with x is equal to the fifth root of 10.